Welcome to Superlab Iod504. Determine how the variable or the value of one variable changes as another variable changes in a complex data presentation. Today what we're going to do is we're going to go through the background information on the skill. We're then going to go through the passage, work on some practice questions on our own, make sure that they're right. By the end of this video, you should be able to answer any question on the Iod504 skill sheet and then master the quiz online. Let's get started. Do we have a volunteer to read the background information at the top of the page? At home, you should be following along with us as we have our reader read.
Iod504 asks you to create a relationship between two variables. This means you need to figure out what happens to one variable as you increase another variable. You should start by looking at the first variable listed in the question. You then need to find the direction that the data is moving and increase, decrease, etc. When you find a relationship, we and the ACT use a common limit. As one variable blank, the other variable blank. The blanks would be filled using one of these five options. Increase, decrease, remains constant, increases, then decreases, decreases, then increases. Sometimes you can also mix some of these relations together and look at the rate of increase or decrease.
Fantastic. All right, so one key thing here is that you usually want to start with the first variable increasing, but you don't have to do that all the time. Let's take a look at the passage about the glaciers. Do we have a volunteer to read through the passage about the glaciers? Fantastic. Thank you. So as our volunteer is reading the passage, what you want to be doing is you want to be circling any words that you find that are tricky or confusing or that you don't recognize. This is a strategy that you should use on any practice passage that you have in front of you. You probably don't want to do it on an actual ACT because you won't have time. But anytime that you're going through a data passage like this where you have essentially unlimited amount of time, you want to make sure you understand all the vocabulary. So as our reader is reading, just circle or underline or somehow highlight any word that you find that's tricky or that you don't recognize so that we make sure that we totally understand this passage before we move on. All right, reader, whenever you are ready.
Today's passage is between what are instances and that important figures in North America. Lakes become a larger glaciers than several lakes. Broad walls, passing lakes, glacier sediments, provide information about the carbon at a time, sediments were discovered. Figure 2. So the cross-section of 17 lake plate and glacier sills and sidewalks in the area. Figure 3 shows estimated values of groundwater, taken from samples of the top 40 meters of sediment at 3 sites along the same crossing. Estimating the calculated elevation of 2 oxygen isotopes, like isotopes, 180 and 150 in the groundwater. Smaller estimated values indicate cooler average.
All right, so take a minute and go back through, and any words or terms that were tricky or confusing, we want to go through and circle or highlight right now so that you can understand them all by the time you see them in a passage. Do we have anyone who wants to volunteer one of the words that they circled or highlighted or underlined? Yes, sir.
Isotopes.
Isotopes. Isotopes near the bottom right here. Good. Another one?
Sediments.
Sediments. Sediments is... Great. Other one?
Dam.
Dams. Nice. Excellent. Any other ones? Just these three? All right, the last one I'm going to circle just because it's important to understand is this idea of a ratio right here. We've probably used it in math before, but we're just going to talk about what it means in terms of science. So as we start to take a look through some of these terms, there's 3 different ways that you can know terms when you see them in a passage. You can either use background information or context clues as the first way. Sometimes it's actually defined for you in the passage. And then the third way is to look it up. All right, on the actual ACT, you can't look it up. So we try to avoid that strategy as much as possible. So let's try from this first word right here. So this word dam. Does anyone see the definition in the passage? No, it's not there. So let's try to use some context clues. Does anyone know what this word means, the word dam? Yeah, essentially trapped or blocked. All right, so it's you kind of have a river that would look like this and it's flowing in one direction. And what you would do is you would essentially create a structure that would stop the water from flowing. All right. Obviously, when this happens, what starts to happen on this side of the river? Yeah, water really starts to back up. If it backs up too much, then it will actually overflow over the top of the dam. All right, but this is how a lot of lakes and rivers are joined. Is that usually either wild animals or like a tree will fall or something like beavers are notorious for doing this. They'll build a dam on a river and they'll back up the whole rest of the river, and it actually turns into a lake because of the animals that work there. All right, humans can do this as well. Like the Hoover Dam is a giant dam that exists, and it actually you can make electricity from the water that goes through the dam, and the dam actually powers all of Las Vegas from just one dam, which is really interesting. All right, so that's the word dam. Sediments. Does anyone know what a sediment is?
You know, like the axle, the partial.
It actually has to do with the bottom of the glacier, stuff on the bottom. Yeah, it's the leftover rocks and junk left behind when a glacier comes in or moves around. Those are what are known as sediments. So it's little teeny rocks or things like that that are left behind. And then last but not least is this word isotopes. Now this is a chemistry review. All right, what does the term isotope mean?
That's the thing that speeds up something.
That is a catalyst, which you're thinking of. Good use of chemistry knowledge, though. All right, isotope instead refers to, all right, they're both oxygen in this case, so our two isotopes are either 18O or 16O. So they're atoms that have the same number of protons, which makes them oxygen, but they have different numbers of neutrons. All right, the different numbers of neutrons are what makes them isotopes. All right, now the reason that they're useful here is because you can actually make a ratio of them. All right, what starts to happen is that 18O, so oxygen with 18 neutrons in it, is actually more likely to be formed in warmer temperatures. So if there's lots of 18O, that means that it's warmer. Where if there's lots of 16O, this forms at cooler temperatures. All right, so that means if you look at the ratio of 18O to 16O, you can actually learn about the temperature that you see in the last sentence there. All right, so can anybody tell us what we can then tell based on the ratio? All right, how can you connect the ratio of 18O to 16O? And how can you connect that to temperature? How can you actually tell about the temperature? Good, so smaller values or larger values?
Larger.
Larger values are warmer, you're right, and smaller values are cooler. All right, so we need to make sure that we're aware of this because it's going to come up later a lot in one of the passages. All right, so now let's take a look at the different figures we have. We have figure 1, which for the purpose of this, we actually can't gain a whole lot of data from. All right, figure 1 is really just kind of there for fun. It shows you where the glaciers are if you were just kind of curious, right? We are right here. The glaciers are a little bit north of us, all right, the lakes that were left behind. All right, but a couple of things that you can see, or you can see the different sites that we're going to be referring to later, site 1, site 2, and site 3. But other than just general information, this figure is actually not a whole lot of data used in this passage. This one is, though, all right, and this could be one of the trickier passages that you see depending on how you look at it. All right, what type of graph does this look like? If you had to describe this type of graph, what type of graph does this look like?
A line graph?
It does look like a line graph. It looks exactly like a line graph because it's got axes on it and it's got lines on it. The tricky part is this is not a line graph. All right, if we look back in the passage, we actually see that figure 2 is a cross section. All right, what that means is it shows you the side view of what we're looking at. All right, where this starts to get tricky is as we follow our lines. If this were a line graph and you saw this line moving up, it would look like the lake clay is increasing in that area over that period. But since it's not a line graph, instead it's a cross section, you have to compare amounts that are there. So in this case, if we followed that same direction, we'd have to compare the amount of clay right there to the amount of clay right there. And you would see that the amount of clay actually decreases. So even though this line here is actually moving up, the amount of clay is actually decreasing. And that's one of the trickiest things to see in here. All right, and if you can really see this one trend of this graph, that it's the amount of stuff, not the direction of the line, it really starts to help you out. All right. The other graph that we see are the ratio graphs that we were talking about before of S18O to S16O. All right. You see it for 3 different sites, and they're the 3 different sites that we were talking about here, here, and here, and they're actually the same sites that are listed here, here, here. All right. If we take a look at those 3 sites, what could we learn by these graphs? All right, if we were to compare these graphs, what could we learn by comparing these 3 graphs? What are they going to tell us? Yes, sir.
The depth compares to the temperature.
Excellent. The depth on our y-axis in this case versus temperature on our x-axis. Now, here's the tricky thing. It doesn't say temperature anywhere. So how do you know that this graph is comparing depth to temperature? Excellent. The larger S18O ratio values, so the larger ones are actually warmer, and the smaller ones are cooler. All right, so it's kind of a roundabout way of describing temperature. All right, but there's going to be some questions that come up about temperature, and so we need to know which way is which. The smaller ones are cooler, the bigger ones are warmer. Okay. As we start to take a look through the rest of these questions, now what we're going to do is examine these figures. Now, one thing that you really need to be aware of is that you're going to have to follow trends in these figures. All right. Now, as you follow trends in these figures, one of the another kind of trick to some of these graphs is taking a look at the direction that the depth is moving. As you move down this graph, are you increasing the depth or are you decreasing the depth?
Increasing the depth?
Yeah, you're actually increasing the depth. You're going from 0, which is a small depth, to 40, which is really deep. So another tricky thing about these graphs is that as the depth increases, you actually have to move down the graph, which is maybe something you're not typically used to. Usually when you see increasing as a word, you want to go up the graph. But in this case, that's not the case. All right. The last thing you need to be aware of is how these lines move. You'll notice that in site 3 and site 1, all right, the line moves generally only in one direction. All right, it starts here and moves to here, or it starts here and moves to here. All right, how is site 2 different than site 1 and site 3? All right, how is site 2 different?
From where it starts and how it curves.
Yeah, it curves. It's not a straight line. Because you'll notice that if you start at the really deep point here, it actually has to go back to here before it moves up. All right, which is another really important thing to see about this graph. All right, so if we take a look at a example question for this graph, we'd be fill in the blank. According to figure 3, as the S18 increased at site 1, the depth of the sample did what? All right, and in this case, it actually should be decrease. All right, that was just put on there to trick you. All right, so as you look at this, let's take a look at the reason why. All right, this is actually an old version of it. If you picked up a new skill sheet recently, you should have it right in front of it. So we're looking at figure 3, and it's always helpful to underline things as you go along, because you might lose track. S18 increased, site 1 depth are some really key words that we're going to need to look at. So we need to look at figure 3. We need the S18O values. Specifically, we need site 1. Now, if we flip back to the question, we're looking at, as those values increase, what happened to the depth? So as we increase the values, that means we're starting smaller and getting larger. This line moves that way. So as we're increasing, we're going from left to right. All right, because the smaller ones are on the left side and the larger ones are on the right side. As this happens, what happens to the line? Does the line go up or does the line go down as we move from left to right? Up. It moves up. That means as the line moves up, is that less deep or more deep?
Less deep.
Less deep. And that's why the answer to this question is that the depth actually decreases because it becomes less deep as you move in that way. All right, so the answer here should actually be decrease. What you want to do right now is you want to try the next 4 guided practice questions on your own. At this point, if you're watching at home, you should pause the video. All right, pausing the video will give you time to answer the 4 questions on your own. Use the hints that are provided. Once you've answered questions 1, 2, 3, and 4, you can press play again to go through the answers together. All right, welcome back. If you are pressing play at this point, you should be ready to go over the answers for questions 1, 2, 3, and 4. So make sure you are not pressing play if you haven't finished questions 1 through 4 yet. You're about to hear how to get them and what the answers are. So let's get started with question 1. Question 1 says, according to figure 2, as the amount of bedrock decreases, the amount of lake clay does something. And the hint is given at the far left of figure 1, there's a lot of bedrock. As you move to the right, the amount of bedrock decreases. What happens in general to the amount of clay? Here, remember, it's important to ignore really little fluctuations. You're looking for bigger patterns overall. So let's take a look. According to figure 2, how would we get this question? Yes, sir.
Well, you have to, like the hints that start at the left.
From the far left?
Yes, and as you see, as you continue to go down, keep going, it starts to decrease right there. And then if you go to clay, and start at the far left too, as you see, if you go to the right, it starts to get bigger. The amount starts to increase.
Perfect. Fantastic. So as you start at the left, where there's a lot of bedrock, and you move to the right, so it stops decreasing. Now this is an important point to recognize here, that it only decreases from here to about here. So that's as far as you can look. You can also do this problem in the exact opposite way, where you could start on this side and notice that it decreases as you go until right here. Either way will give you the same answer. All right, and what you'll notice is that on these sides right here, there's only a little bit of clay, but as you move to the point where it's decreasing, look at all that. Lots and lots of clay. So this clay, in this case, we are increasing. All right, next up, as you move from site 2 to site 3, the overall elevation does what? And the hint is given, elevation is listed on the y-axis of figure 2. What happens to the surface elevation as you move from site 1 to site 2? Do we have any volunteers to go through question 2 for us? Thank you.
So, as you go to figure 2, start at site 2, when you just put your 2 fingers on it, but when you get to site 3, it increases.
Excellent. So if you start at site 2, and remember, we're looking at just the surface elevation here. So in here, you can almost treat it like a line graph. All right, you're watching the surface go up. So it starts here at site 2 and moves up all the way to site 3. You'll notice that it only increases over this point from 2 to 3. The only thing it should do in this case is increase. All right, you're just looking at the surface when we're talking about elevation. All right, next one, number 3. According to figure 3, as the depth of site 2 increases, the S18O found in the sediment is what? And the hint here is that site 2 is in the middle of figure 3. As the depth increases, means you move down the graph, what happens to the S18O values? And it should do 2 things, according to our hint. All right, how would you get this question?
Okay. First, you gotta look at the middle graph.
Look at the middle graph.
And since looking for the depth decreasing, we start from the right side of the graph.
Wait, we're looking at the depth as what? As the depth
Increase.
Good. So we're looking at the depth increases, which means that we move which way?
From right to left. Oh, down.
Down. Good. You move down because you're looking at the depth increases. So it's got to start small and end big. So that means we need to look this way down the graph. The depth is increasing. Now then, what happens to our S18O values as the line follows that path?
It decreases, and then it increases.
Excellent. So the first part, as we move down, it goes this way, and it decreases. It goes to the left. But then you'll notice that it cuts back again, which means it goes to the right, which means it increases. So our answer here should be 2 parts. It should be increases first from the point right here. I'm sorry, it should be decreases from the point there. And then after that, it should increase from that section. So decrease, then increase. Fantastic. All right, let's take a look at the last one then. How would you answer the last question on here, question number 4? Do we have any volunteers to answer question number 4? Fantastic.
Okay, so first we look at figure 3, and then we look at, so we look at it, and then it says, and you have to find, if increases or increases.
Good, so if it decreases, and which site are we looking at?
1.
Site 1, good. So we need site 1. This one over here.
And then you try and know it's decreasing, so you go down.
Good, so we know the depth is decreasing.
Yeah.
So it's becoming less deep. So do we move down or do we move up?
Up.
Good, we move up because it's becoming less deep. So we start at 40, which is really high, and we end at 0. So the depth decreasing means we move that way.
And you look at the temperature.
Now, how do you find the temperature on here again?
By the numbers at the top.
Good, so which side is colder, on the left or on the right?
On the left.
Good, so the left is cooler over here with lower S18O values, which means this way is warmer. That's what we had talked about before. So as this line moves up, it also moves which direction? To the left or to the right? To the right. Which means that the temperature, if it moves to the right, becomes warmer or cooler?
Warmer.
Warmer, right? Because it's moving to the right, so it becomes warmer. Which means that the temperature increases or the temperature decreases? Fantastic. The temperature should increase. All right, at this point, what you want to do is try the next set of questions on your own, the self-practice questions, questions 5 through 9. All right, once you are done answering questions 5 through 9, press play on the video, and we'll go through how to answer each one of the questions. Good luck.
According to figure 2.
At this point, you're ready to press play if you've answered questions 5, 6, 7, 8, and 9, and are ready to go through the answers. Let's get started at question 5. According to figure 2, as the thickness of the lake clay deposit increases from Grand Forks to Site 3, the thickness of glacial till beneath it does what? Would anybody like to volunteer and answer question 5 for us? Thank you, ma'am.
It decreases
How did you get decreases?
because you have to go to the ground force to Site 3.
All right, so if we look from Grand Forks, which is right here, to Site 3, which is right here.
The thickness of the glacial till beneath it.
All right, so if we look at the glacial till, starts here like that and ends like that. Is that increasing or decreasing? Decreasing as we move that way. What are we looking? Oh, there we go. The thickness of the glacial till. What does it do? It decreases. Fantastic. Nice. Let's go on to question number 6. According to figure 3, the statement as depth decreases, the temperature increases only is true for which site or sites? Who wants to go through question 6 for us?
3 sites 1 and 3.
How did you get sites 1 and 3?
Because if you look at Site 1 and Site 2, Site 1 and Site 3, like when the dust increases, it increases.
Excellent. So in this case, we're looking, as the depth increases, should go in which direction? Up or down?
Up.
Up. So we're looking for something that goes up, and as it goes up, should it go to the left or go to the right?
To the right.
To the right, because we want the temperature to increase. So we essentially want a line that goes up and to the right, which means the line should look like that. The only two where the line looks like this are this one and this one, Site 1 and Site 3. You'll notice that Site 2 goes left before it goes right. So that one can't count, which means this must be 1 and 3. All right, let's take a look at question number 7. According to figure 2, as the site number increases, the amount of bedrock below the site does what? Would anybody like to go through number 7 for us?
It decreases.
How'd you get decreases?
Because when you look at the site numbers, Site 1, Site 2, Site 3, the amount of bedrock decreases.
Excellent. So you're only concerned about this area where the 3 sites are. And do they increase from left to right or right to the left? Yeah, from left to right. Good. All right, so from 1 to 2 to 3, we're looking from left to right. So as we follow bedrock from left to right, what happens to the amount of bedrock? Yeah, it goes down. So if we follow the bedrock this way, you'll notice that there's more here than there is here, so that's decreasing. Nice. All right, 2 more. Let's look at number 8. Do we have any volunteers who want to go through number 8? Thank you, ma'am. All right, so the question says, according to figure 2, as you move from site 2 to site 3, what happens to the elevation? And what'd you say? How did you get increases?
So I was figured so and it's like I do expect to the 30, what happens to the elevation and it goes up.
Excellent. So from site 2, moving over to site 3, the elevation increases. Nice. Perfect. All right, because you see the surface actually rise. Last but not least, number 9. According to figure 2, as you move from Winnipeg to Grand Forks, the amount of bedrock, what happens there? Anybody want to do number 9 for us? Thank you, sir.
I think C.
C?
That you can,
How'd you get that?
because you start from Winnipeg to you go right to Grand Forks.
Excellent. So you want to
Or
go this way?
Bedrock.
Yep.
To the north.
Excellent.
So at first it's really high and then it shrinks, like it gets smaller
Nice. Shrinks for a while, and then what happens?
and then it starts to go up.
Excellent. So if you follow the whole path from here to here, it decreases, and then as you continue, it increases again, which means that it decreases, then increases. Fantastic. If you've gotten all these right and you feel like you're confident about it, you are ready to take the test. Good luck.